Okay, today we're talking about section 3.3, prove lines are parallel, and it starts out with a postulate, postulate 16, and it's called the corresponding angles converse. Now, I remember the word converse. It's a special word that whenever you have a conditional statement, you can form the converse by exchanging the hypothesis and conclusion. So that's what I'm going to be expecting as I read through this right here. So let's see if I can identify the hypothesis. It says, if two lines are cut by a transversal, so the corresponding angles are congruent. Okay, so it looks like that's the hypothesis. Two corresponding angles are cut by a transversal, then the lines are parallel. And then it says, if that's true, then the lines will be parallel. Now, you might be thinking this is exactly the same postulate that we learned yesterday, but it's actually slightly different. Let's take a look at what is slightly different. All right. So before, let me highlight it again, we had that the hypothesis was two lines are cut by a transversal, so the corresponding angles are congruent. So if we know that the corresponding angles are congruent, then we can be sure that the lines are parallel. But in this other one, it says if two lines are parallel, if two parallel lines are cut by a transversal. So this one says if the two lines are parallel, then we know that the pairs of corresponding angles are congruent. And that's why this one, right, the one that we learned yesterday is called the corresponding angles postulate, and the one we're learning today is called the corresponding angles converse, because it's almost the same, but with the hypothesis and the conclusion exchanged. So basically, to summarize it, the one from yesterday says that if the lines are parallel, and I'll use a special symbol for parallel, just straight up and down line segments like that. If lines are parallel, that means that corresponding angles are congruent, and I'll use a special symbol for congruent. Remember, congruent means that they have the same size, the same amount of degrees. And then the postulate that we're learning today says that if the corresponding angles are congruent, so if the corresponding angles are congruent, then that means that the lines are parallel. So almost exactly the same, but they're just converses of each other. That means if you wanted to, you can combine these into one biconditional statement that says corresponding angles are congruent if and only if the lines are parallel. So just remember that. You can do that if you want. All right, on to the next slide. We'll see that now we have also the okay, I actually had the wrong thing for a second, but now we have the right thing. And you'll notice that they're all the same, almost exactly the same as what we learned yesterday, except they're all converses. So now, instead of it saying if the lines are parallel, then the alternate interior angles are congruent, it just says it the other way around. It's also true that if these two alternate interior angles are congruent, that means that the lines are parallel. Or if for the alternate exterior angles converse, let's look at this next one. It says if two lines are cut by a transversal, so the alternate exterior angles are congruent, then the lines are parallel. So if these two alternate exterior angles are congruent, then that means that you can be absolutely sure the lines are parallel. And then just one more theorem. It's the converse of another one from yesterday, the consecutive interior angles converse. It says if two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So basically, if these two angles Let's see here. Two angles in here. If they add up to 180 degrees, if they're supplementary, then that will mean that the two lines are parallel. It only happens when your two lines are parallel. If the lines weren't parallel, they would have added up to something else, maybe 170 or 160 or something else like that. Okay, now I'm going to work out a few problems with you from the homework to get you started, and then the rest will be for you to do for homework. So the first question, is it possible to prove that the lines are parallel? If so, state the postulate or theorem you would use. And we have information about two angles, these two right here. Now I take a look at them, I can see that they are formed by a transversal cutting through two lines. It doesn't say that they're parallel, and I have to figure out, is it possible to know if they're parallel? These two angles are on the same side of the transversal, so they're not alternate interior angles. Looks like they're consecutive interior angles. They are both between the two lines, so I see that they're between these two lines, and they're both on the same side of the transversal, so they are definitely consecutive interior angles. And if these two lines, P and Q, really are parallel, that means that these angles would add up to 180. So let's check and see if they do. 122 plus 58, 2 plus 8 is 10, carry the 1, 1 plus 2 plus 5, 80, and then 1 plus nothing is 1, 180. Yeah, these are definitely, and I will just say that the consecutive interior angles are supplementary. That means the lines are parallel. That means the lines are parallel. If they had added up to something else that wasn't 180, that would have meant that the lines weren't parallel. Even though they look parallel, they might be slightly off. The angles might add up to 179 or something. All right, next problem. Okay, we're going to do number 4 now. It says find the value of x that makes m parallel to n. Notice how they use this new thing to show parallel. And we have these two lines, m, which is right here, and then we have the line n, which is this one down here. It's also transversal going right through there. Let's see. How would I do this? I see that I have 2x right here. And that's one of the interior angles because it's between the two lines. But 100 is an exterior angle. I think I need to find another angle. I think I'm going to try and find, let's see, this angle right here, because it's a corresponding angle to the 2x. And I know that these two angles right here would add up to 180 degrees. So let me just figure out what should go in that yellow spot. So 180 minus 100 is equal to 80. So it looks like this angle over here is 80 degrees. And now, in order for these two lines to be parallel, the corresponding angles have to be the same size. So that would mean that this 80 right here and this 2x right here would have to be the same. So I just have to figure out what x would have to be for that to be true. 2 times something, it has to be the same as 80. So you could guess a few times, you could figure it out, or you could divide by 2, but we figure out that x would be 40 in this situation right here. All right, we'll also try number 7. Number 7 shows 2 lines and a transversal. So let me highlight the 2 lines and the transversal. And we're trying to figure out what x has to be so that these 2 lines will be parallel. So I take a look at the two angles. I have this angle right here. It's in between the two lines, so it's an interior angle. I have this angle over here. It's also in between the two lines. It's an interior angle. And look how they're on different sides of the transversal. That means they're alternate interior angles. And the only way these two lines are going to be parallel is if the alternate interior angles are equal to each other, if they have the same degrees. So I have to figure out how to make 4x equal to 6x minus 44. I have to figure out what number I could put in for x that would make this true. So I think I'll take away 4 x's on both sides of this equation. Then I'll have nothing left over here. And then I'll have only 2 x's left over here. And I'll still have a minus 44 left. I think at this point, since I have a minus 44 on the right side of this equation, I'll add 44 to both sides. Since I have nothing on the left side, and if I add 44, now I'm up to 44. On the right side, if I add 44, it'll add up with the negative 44 to 0, and all that will be left is a 2x. So I see 2 times something equals 44. That's 22. Alright, so there's my answer. There was kind of a lot of steps there. I feel like I should check and make sure, see if that really works. So let's do 22 times 4, and I get 88. Okay, good. Then let's do 22 times 6. 22 times 6, that'll be 12, carry the 1, 12 plus 1, 132. And now also subtract 44. So let's subtract 44. And I get, let's borrow, so 12 minus 4 is 8. Oh, I forgot to put the 2 there, little 2. I'm going to have to borrow again. 12 minus 4, 88. Yeah, so look how I got the same thing for both of these, for the 4x and for the 6x minus 44. So it looks like I chose the correct x. So that's correct. Alright, so the rest of the problems are for homework.